Hello everyone. Today I'll be talking about the physics from Interstellar. Since it contains a lot of physics, I will specifically look at the physics behind the wormhole. Before I discuss wormholes, here's the clip from the movie that portrays the wormhole.
Any trick to this, Doyle? No one knows. Now the others made it, right? At least some of them. Everybody ready to say goodbye to our solar system? To our galaxy. Here we go. The controls won't work here. We're passing through the bulk. Space beyond our 3 dimensions. All you can do is record and observe. What is that?
It's them.
Distorting space-time. Don't!
Now that you have seen the clip, hopefully you can somewhat understand what a wormhole looks like, at least through the movie's portrayal. Whether their portrayal is realistic or not will be discussed later on. Now to define what a wormhole is. A wormhole is basically a theoretical passage through space that creates a shortcut through space-time. So to put it in simple terms, it is basically when you have 2 points on a plane. And now imagine that you are at point A, which is here, and you want to reach point B, which is here. But the distance you need to travel is very, very far. And it would take a very, very long time for you to reach go from point A to B. And so now imagine this plane, which is space-time. Imagine it curves due to gravity. And now point A and point B are practically side by side. Yet there's still a gap between them. Now between this gap, a wormhole would form and create a passage between the 2 points. Now the very large distance that you needed to travel can be made in a matter of seconds, if not instantaneously. This may not be very accurate as physicists are still unsure of how the wormholes form, but this will give you an idea of how traveling through wormholes work. Since we now have an understanding of what a wormhole is, let's go back and discuss how the idea originally was introduced and some of the theories that were created based off the introduction of this idea. Okay, so the idea of a wormhole was first actually introduced by an Austrian physicist named Ludwig Flamm. Flamm looked at Schwarzschild's solution, which describes a particular type of black hole. When Flamm looked at the solution, he noticed that another solution was possible for a white hole. A white hole is the opposite of a black hole, meaning it ejects things instead of pulling in things. And so with these two solutions, he thought that mathematically there could be a space-time connection between the two. And between the two, there's some conduit. And the black hole, he assumed that the black hole would be some sort of entrance and the white hole would be like an exit. And it could probably be in the same universe or different universes. Later in 1935, Albert Einstein and Nathan Rosen revised his theory and developed it further. As Flamm did not take it as seriously, he just proposed the idea. Albert Einstein and Nathan Rosen wanted to go in further, and they developed theory for the wormhole. And so the wormhole was theorized using the theory of relativity, which is a theory about how gravity curves and warps space. The theory helped develop the idea of bridges through space-time. These bridges would connect 2 points in space-time and create shortcuts that can reduce time and distance. This idea of bridges was called Einstein-Rosen bridges, and later on it was known as wormholes. So both Einstein and Rosen thought that the surface of a black hole could possibly be bridges to another point in space. And so a black hole consists of a singularity, which is a point of infinite density, and it also consists of an event horizon, a region surrounding that singularity beyond which nothing can escape. So according to the Physics of the Universe, which is a book, they found that they could extend the solution to include polar opposite of black holes, like I mentioned, which was white holes. And these hypothetical white holes also contain a singularity, but they work in reverse. So they work in reverse of a black hole. So like I mentioned before, they eject things. And so to prove this, they started with the mathematical solution of a black hole. And this solution was used, the solution that was used was Schwarzschild's metric. And Schwarzschild's metric was created by Carl Schwarzschild in 1916. And it basically describes the gravitational field outside of spherical mass, given some few assumptions that were made. And so this also resulted in people calling them Schwarzschild wormholes. Anyways, Einstein and Rosen used this equation and changed some things, and they ended up removing time as a variable that could affect the metric. With all this derivation, it indicated that 2 points that are billions of light years away can be traveled in no time. So in summary, Einstein and Rosen were able to introduce this idea of wormholes for future physicists to prove, as they weren't able to prove its existence. There are many theories that are revolving around this idea that was theorized by Einstein and Rosen back in 1935. And there's this one theory where humans thought it was possible for wormholes to be created. And in order to do this, they would need something with negative mass. And they would need this negative mass to go against the gravitational attraction that is created, or is present actually. And if something or someone were to enter a wormhole, the gravitational attraction would actually try to close the wormhole. And so thus they would need something to actually keep it open so that they could go through the wormhole and return back safely. And they theorized that they would need something atypical, something unusual that they don't have, which they called exotic matter. Another theory involves quantum entanglement. Now, quantum entanglement is basically when two quantum particles in space are linked together in a special way. And it makes it so that their link makes it so that no matter how far apart they are, they always stay in the same state. So, for example, if you were to stretch one of the particles, for example, or spin it or fiddle with it or do something with it, the other particle would also behave in the same way, and it would stay in the same state. So, then the theoretical physicists have theorized that there may be a connection between quantum entanglement and a wormhole. Though they believe that there is a link between the two, there are many reasons why they think otherwise. For example, quantum entanglement cannot be used since the signals cannot be sent faster than the speed of light. And there's also the problem with the wormholes. If they talked about how wormholes could be connected by two black holes, but the problem would be that you wouldn't be able to leave if you were to enter, because black holes suck in everything and they don't eject. And so they also have thought of other possibilities other than two black holes. They theorized that it would be possible to create a connection between two quarks. And a quark is an elementary particle that makes up protons and neutrons. And so then the two scientists by the name of Kristen Jensen and Audrey Karch started by imagining a quark and an anti-quark in 3D space. And they stated that it will almost reach the speed of light, making it impossible for the quarks to send each other's signals. They suggest that quarks in 3D space reside in a hypothetical boundary of the 4D world. And so in 3D space, the entangled pair would be connected by some string, and they thought that in 4D space then it'd become a wormhole. And so the further research comes with many different conclusions. As they reach further into this topic or theory, there's many conclusions that they made, and some were complicated, some went back and forth, and there are many complications. But anyways, with wormholes there comes many problems, and problems with creating wormholes and not being able to spot any is two big things. Some problems with creating ones are danger of sudden collapse, high radiation, dangers with exotic matter. There are two challenges that prevent visibility and usability, which are tininess and fragility. There's this type of wormhole called primordial wormholes, which are very small. As you can see, it's 10 to the power of negative 33 centimeters. And but it is said it is possible that these wormholes might get bigger as the universe expands. But the chance of that is very low, and time it take would be probably a very long time. There is also the possibility of wormholes collapsing when we enter, and so that would cause problems as you wouldn't be able to make trips there and back. And so we would, like I said, mentioned before, we would need exotic matter to keep it open, which we really can't produce large amounts of. Now moving on, the final question. Is the movie's portrayal of the wormhole realistic, or is it a myth? Well, it's hard to say, as both sides, there are reasons for both sides. And so the movie's portrayal does have some aspects of realistic wormholes, and there are some myths that are involved. Though the realistic aspects cannot not also be considered realistic because wormholes are mostly speculation. As we do not have any concrete evidence of the existence of wormholes, it would be hard for us to say if the wormhole is a myth. And so there are some aspects that the movie portrays correctly and some that are portrayed wrong. One aspect that is portrayed right is the shape of a wormhole. In 2D space, the wormhole would be like a circle. So in 3D space, it'd be a spherical shaped gravitational body. And this gravitational body reflects the other side of the wormhole, which is something that which is what you saw in the video, in the clip. And so those are two things that are portrayed correctly in the movie. As for something that is portrayed incorrectly or not in the right way, is the speed or the time it takes for you to travel from one point or from one entrance of the wormhole to the other. And in real life, in a wormhole, it is speculated that it would be instantaneous and there would be almost no time between the travel. But for entertainment purposes, the movie considered putting in the whole 10 seconds, 20 seconds of the clip of them traveling through the wormhole to see galaxies, stars, a bunch of other things. This is all for entertainment purposes. The physicists behind the movie said that most of the things we know about wormholes are mostly speculation, as we do not have much evidence that actually proves their existence. And so, with that being said, in the end, it is hard for us to say whether these gravitational bodies are real or not, as there are many theories, but not much evidence that proves their existence. So until we get evidence, or until we prove that these are wrong, it's hard for us to say whether wormholes are real or not. Though with what we have, I would say that the movie portrayed the wormhole well, in a good manner that wouldn't be too different from the ones that we speculated. Obviously there are reasons for them to change things up, but most of the aspects of the wormholes are very close to what people speculate in real life. Thank you.